In this video, we are going to learn how to solve these physics repeated questions under capacitance in series and in parallel together with energy stored in a capacitor. So we're going to practice with 10 repeated questions for this topic. Let's get started. First one here says, calculate the effective capacitance of the circuit above. Okay, so in this circuit above, basically, the first thing to note here is that the connection we have here from these 2 microfarad to here, they are connected in parallel. So since it's parallel connection, is going to be 2 plus 2 plus 2. So this will give us what 6 microfarad. Alright? So this is my symbol for macro. Now, the next thing to do is that these 2 microfarad and these 3 microfarad we have here, they are connected in series. So now that we have converted this parallel connection to series, it's going to be 1 over C equals, this is the formula for calculating capacitors connected in series. So 1 over C equals 1 over 6 plus 1 over 2 plus 1 over 3. So the LCM is 6. So we're going to have 1 plus 3. 2 into 6 is 3 times 1 is 3 plus 2. 3 into 6 is 2. 2 times 1 is 2. So we have 6 over 6. Remember, we have 1 over C here equals 6 over 6. When it cross multiply, we're going to have 6 equals 6C. Divide both sides by 6. So your effective capacitance will be 1 microfarad. So the right option in this question is option B. That's it for this question. Let's wipe this now and solve the next repeated question. So the next repeated question will be this question. It says 3 capacitors of capacitance 2 microfarad, 4 microfarad, and 8 microfarad are connected in parallel, and a potential difference of 6 voltage or 6 volts is maintained across each capacitor. The total energy stored is, so for this particular question, note that the formula for calculating the energy stored in a capacitor is half CV square. Alright, now let's get the parameters. We have the capacitor there, we have it to be these values connected in parallel. So it will be 2 plus 4 plus 8. You get the sum. So that will give us 14 microfarad. So we are going to have half, okay, times 14 times 6 square times 10 to the power negative 6 because of the macro. They are very, very important. So let's punch this the calculator. So this is 1, okay, let's say 14 times 6 times 6 times, now 10 to the power negative 6, something as 0.000001. Okay, divide this by 2. So this is output. Now note that when you punch this on the scientific calculator, this calculator we have here is not scientific. So when you punch this on the scientific calculator, you're going to have an output of 2.52 times 10 to the power negative 4. So the right option in this question is option D. So this value in option D is equivalent to what we have here displayed on this calculator. So the right option is this option D, 2.52 times 10 to the power negative 4 joule. That's it for this question. Let's wipe this now, solve the next repeated question. So the next repeated question will be this question. It says the resultant capacitance in the figure above is, so in this figure above, this capacitor and this one here are connected in series. This one here is also connected in series, but these 2 are connected in parallel. So let's convert this parallel connection to series. It will be 2 plus 4. Okay, so this will give us what 6 microfarad. Now we now have 6 in parallel connection with this already 3 here. So now get the resultant capacitance, that the effective capacitance will not be 1 over C. Remember, this is the formula for calculating effective capacitance in series. So it will now be 1 over C equals 1 over 2 plus 1 over 3 plus 1 over 6 plus 1 over 4. So the LCM here is, so this will give us 12. 2 into 12, we have it to be 6. 6 times 1 is 6 plus, this will give us 4, this will give us 2, this will give us 3. So we have 1 over C equals 6 plus 4 is 10. So we have 10 plus 2 plus 3, we have 15 over 12. When you cross multiply, you're going to have 12 equals 15c. Divide both sides by 15. So let's punch on this jumbo calculator. We have 15 divide, okay, sorry, we have 12 divide 15. So we have it was 0.8 microfarad. The right option is option D. That's it for this question. Let's wipe this now, solve the next repeated question. So the next repeated question will be this one. It says the equivalent capacitance for the circuit done is, so this is also very simple. We have, let me remove this. So we have these two capacitors are connected in parallel, so convert them to series connection. It will be 7 plus 5, which will give what 12 microfarad. So the equivalent capacitance now will now be 1 over C equals 1 over 6 plus, this is 6 guys, plus 1 over 12. So the LCM is 12. This will give us 2 plus, this will give us 1 equals 3 over 12. So remember we have 1 over C equals 3 over 12, cross multiply. You have 3C equals 12. Divide both sides by 3. So your C will be what? 4 microfarad. Right option is option B. Alright, it's as simple as this. Let's wipe this now, solve the next repeated question. So the next repeated question will be this one. It says a supply of 400 volts is connected across capacitors of 3 microfarad and 6 microfarad in series. Calculate the charge. Okay, so to calculate the charge, we're going to basically make use of this formula. Capacitor equals charge over voltage. So we have series connection here for the capacitor. So this tells us that it's going to be 1 over 3 plus 1 over 6, 1 over C equals this. LCM is 6, so we have 2 plus 1, could you give us what? 3 over 6 equals 1 over C. Cross multiply, you have 3C equals 6, divide both sides by 3. So effective capacitance is 2 microfarad. So when you plug the values in this formula we have, we are going to have, remember we're looking for the charge, which is this parameter here. So it's going to be 2 microfarad times, let's convert the microfarad to farad. It will be 2 times 10 to the power negative 6 equals our charge over the voltage is what? 400. So when you cross multiply, you are going to have, let's punch this on the jump calculator. 400 times 2 times 10 to the power negative 6, then now 0.000001. So that's it. Press equal to. So another way you can express this in standard form is, let me show you so that to be on the same page. We have 0.0008. so when you move 1 2 3 4, so it will give you 8 times 10 to the power negative 4 charge. That will be the answer. The right option is option C. Okay, so that's it for this question. Let's wipe this and solve the next repeated question. So the next repeated question will be this one. It says the diagram above shows three capacitors C1, C2, C3 of capacitances. These values respectively, the potential difference across these capacitance respectively are. So guys, for this particular question, though this might take a little time to solve, but it's very simple. Firstly, we need to get the charge for the effective capacitance. So the connection we have here, this is series connection. Okay, so it's going to be, let's get the effective capacitance of this series connection. That will be 1 over 2 plus 1 over 6 plus 1 over 3. So LCM is 6, so we are going to have 3 plus 1 plus 2. So we have 4, now 6 over 6 equals 1 over C. So you have 6 equals 6 both side by 6. So the effective capacitance is 1 microfarad. So now that we have this, to get the charge, we are looking for, okay, to get the potential difference across C1, C2, C3. So we have the effective capacitance to be this. Okay, let's get the effective charge. So it will be this effective capacitance we have there 1 equals charge over the effective voltage we have there 12. So the effective charge will now be 12C. Now, to get the potential difference respectively as C1, C2, and C3, let's begin with as C1. Remember, the general formula or conventional formula is capacitance or capacitor equals charge over voltage. So, for the potential difference as C1, this is our C1. Okay, our C1 is 2 microfarad, so it gives us 2 equals, now our charge, effective charge is 12 over V cross multiply. We're going to have 2V equals 12 divided both sides by 2. So it will give you 6 voltage. For that at C2, we have it to be 6 microfarad. So it gives us 6 equals 12 over V cross multiply. We're going to have 6V equals 12 divided both sides by 6. So your V here is 2 volts. Lastly, for that at C3, the capacitor there is 3 microfarad. So we have 3 equals, we are looking at the effective charge is 12 over V cross multiply. We're going to have 3V equals 12 divide both sides by 3. So this will give you what, 4 volts. So this shows us that when C1 is, this is our C1, this is our C2, this is our C3. When C1 is 6 volts, the C2 is 2 volts, and the C3 will be 4 volts. The right option is option A. That's it for this question. Let's wipe this now, solve the next repeated question. So guys, the next repeated question will be this one. It says the resultant capacitance in the figure above is, I think we have solved this question before. We got 0.8 microfarad. Alright, so let's go to the next repeated question, which is this one. It says two 50 microfarad parallel plate capacitors are connected in series. The combined capacitor is then connected across 100 volt battery. The charge on each plate of the capacitor is. So we're looking for the charge. Firstly, series connection. Let's get the effective capacitance for it. So it will give 1 over C equal 1 over 50 plus 1 over 50. So LCM is 50. So this will give us 1 plus 1. So we have 1 over C equals 2 over 50. When we cross multiply, we are going to have 2C equals 50 by both sides by 2. So the effective capacitance is what, 25 microfarad. So we are looking for the charge. So when you apply this formula, capacitor equals charge over voltage, we're going to have, so remember we have 25 microfarad. So it times the macro value, which is 10 to the power negative 6, equals, we are looking for the charge, which is Q over the voltage given here is 100 volts. So when we cross multiply, we're going to have, let's punch this on the jam calculator. We have 25 times 100 times 10 to the power negative 6, the same thing as 0.000001. So let's see the outputs. We have it to be 0.0025. So if you are putting this value in standard form, so we have 0.0025. If you put this in standard form, this is, you go 1, 2, 3. So this is 2.5 times 10 to the power negative 3 charge. So the right option is what? Option D. Alright, so that's it for this question. Let's wipe this now and solve the next repeated question. So the next repeated question will be this one. It says calculate the equivalent capacitance of the circuit in the above diagram. So the effective capacitance or equivalent capacitance rather, it says calculate the equivalent capacitance of the circuit in the above diagram. So this is series connection, all of them. So this will give us 1 over C equals 1 over 5 plus 1 over 15 plus 1 over 10 plus 1 over 3. So the LCM here will be 30. So 5 into 30, we have 6 plus 2 plus 3 plus 10. So when you add what you have there, you're going to have 1 over C equals, so we have 10, 16, 18, 21. So we have 21 over 30 cross multiply. We're going to have 21 C equals 30. Divide both sides by 21. So your C will be, let's punch this on the jam calculator. So we have 30 divide 21. So the output will be 1.428. If you are leaving it to 2 decimal places, it will give you 1.43. So the right option is option C, which is 1.43 microfarad. That's it for this question. Let's try this now, solve the last question before we end this video. So the last repeated question will be this question. It says from the diagram below, the equivalent capacitance of the tray capacitor is. So this is series connection as well. We have 1 over C equals 1 over 3 plus 1 over 3 plus 1 over 3. So LCM is 3, 1 plus 1 plus 1. So we have 1 over C equals 3 over 3. Cross multiply, you have 3C equals 3. So your C is what 1. So the right option is option A, 1 microfarad. So guys, this basically can deal with problems involving capacitance in series and in parallel together with energy stored in a capacitor for physics. Hope you learned something interesting from this video. We practiced with 10 repeated questions for this topic. Let's call it a video, guys. If you are new to our channel, ensure that you are subscribed to this channel for more of our videos. Also like, share and comment on this video. Tell me how you feel for what I learned from this video. If you seem to have any specific question to ask regarding what I've talked about in this video, feel free to leave a question in the comment section below and I'll ensure to give you a response. Also ensure that you're part of the channel membership by clicking on the join button, where you'll be getting special information and help to simplify your academic work. So having done that, click on the screen above and I will see you in the next video. Thanks for watching.